In this video, I will be covering the basic processing of a proton NMR spectrum using TopSpin 4.5. In the window here on the left side, you can see we have a file explorer. We have many different experiments. Experiment 1 is the proton, experiment 2 is the carbon. So when you're acquiring spectra, this is the formatting that the TopSpin uses for getting multiple spectra of a particular compound. And you can simply click on one and tell it to, or right click and tell it to display, and then process it that way. You can also open spectra by going to this triple bar up here, clicking on it, and going to open. Now I downloaded some data, and that is now going to then be in the downloads folder. So I come here to downloads, double click on that. You can see we have a folder labeled 1. So this is the folder that has that NMR data. I can click on that folder and tell it to display, and it shows the spectrum in that window. And so now we have that. You can see I'm adjusting the intensity or the height of the peaks. I'm using the scroll wheel on my mouse to do that. We can zoom by using the left mouse button. We can click on one side of the spectrum and then move over and zoom in that way. You can undo the zoom using this icon here. This button is going to be a toggle, so we'll go back to the previous zoom. Click it again, we go back to that zoomed in area. If you want to see the entire spectrum, we can go to the icon that's right beside it. You can see there's a show full spectrum, so we click on that and it shows the entire spectrum. Of course, we typically don't want to see all this empty space, and so again we can click drag to zoom in. Now, TopSpin will typically automatically process your spectra when you acquire it. The actual data that's acquired is the free induction decay, or the FID. If we click that button, we can see that. We can zoom in on this as well, and so we can see we've got multiple sine waves, and if we zoom in, we can see we've got more frequencies embedded in that. Processing the spectrum, if we go to the Process tab here, we also have an Analyze tab, but under Process we have a Process Spectrum. If we click on this, it will Fourier transform the spectrum and phase it. Since I have already processed it once, it'll ask if we want to redo that and overwrite the data. Click Yes, and it will reprocess. TopSpin typically does a very good job with the processing, the initial process, the Fourier transform, and the phasing. I'm going to go to the Adjust Phase button to show how we can phase it manually if it's not properly phased. So we're going to click here on the phase, and we see this is a well-phased spectrum. I'm going to adjust the phasing so you can see what a poorly phased spectrum looks like. So this is a poorly phased spectrum. You can see this peak all the way to the left here around 8 ppm. We have it sloping upward instead of being fairly sharp, and then it dips below the baseline before it returns back, and we have that pattern multiple times on these peaks. This one we have just slightly out of phase, but then at this end we have the phasing off again where it's dipping and then going up and then slowly returning back to a baseline. This is poorly phased. When we click the Adjust Phase button, it puts us in here where we have this menu bar or toolbar up above. You'll notice on the spectrum we have this red line here out around 1 ppm. The first step for the phasing is to do zero order phasing on the peak that's underneath that red line. And so we'll put our mouse here on this 0, and you can see it says zero order correction. If we click and then with the left mouse button held down, we can drag this up or down, And you can see we're adjusting that phasing on that peak. We want to adjust it until that peak is symmetrical. So the baseline goes sharply up to the peak and then returns back to the baseline without dipping below it. Once we have that corrected, we can release the mouse button, and now we go to the 1, and at this point we're going to phase the peaks that are farthest removed from that red line. So again, we click, we start dragging up and down until we reach that point where it is well phased. Occasionally you might need to redo the 0 and first order, but typically the first time gets all of that set. And you can see we now have a well phased spectrum. We'll then leave the phasing window. If we don't like what we've done, if we think we've made things worse, we can always go return, do not save, or the next button over, return and save. Since we have a well-phased spectrum, we will click on that. It takes us out of the phasing and gives us a spectrum. This one has already been integrated and the peaks have been picked. However, we're going to redo this. When TopSpin does it automatically, does not do a very good job frequently, and so we do need to redo it. For that, we will go to the Analyze tab, and we will then start with the Pick Peaks. Click on that, and we have an X here. We can tell it to delete all the peak picking ranges and to get rid of what has already been done. And then we can come over to this, looks like a bracket that's fallen over, define new peak picking range. So we'll click on that. Now that it's highlighted, we can click and drag, and you'll notice when I'm doing this that it's creating a box. You want to have the tips of the peaks inside that box. When we release, it will then put the chemical shifts of those peaks above the box. I am going to unselect this button for a moment and zoom in on this region, and then we will go back. So now when we click and drag, we're creating the box for the peak picking rather than expanding. So again, we're going to do a box. Again, just catch the tips of the peaks, and you can see it then gives the shifts of all those peaks. It does pick, you'll notice, a couple on either side here. Sees a couple of smaller peaks. Something I'm going to highlight here with this box, notice that the leftmost peaks are not, the tips are not inside the box. If the tips are not in the box, it will not show chemical shifts for those. So we do not have a chemical shift for this peak because it was not inside the box. To remedy that, we can simply click and drag a new box, one that includes those peaks. And also, of course, we want this third peak from the triplet as well. If your box does not include any of those, it will get rid of all those peaks. So you do need to have the tips inside, and that is a way of getting that shown. But we can use that by how we draw the box to eliminate peaks if we've picked too many, or if we've set a threshold that's too low. At this point, again, I will deselect the regions box. We'll zoom out and then zoom back in, this time on the lower chemical shift region. And again, we'll do our selection, get our triplet here, and you'll notice this center peak of the triplet is off scale. So again, I will use my mouse wheel to bring that down, and then I can do the peak picking and get those peaks. You'll notice I did not pick the outermost peaks from this pentet or from this sextet. When we are doing peak picking, we don't usually need those. If you do need them, of course, you can always reselect to include those peaks as well. But generally, when you are reporting chemical shifts for multiplets, you report the chemical shift from the center of the peak, so you really don't need all of the outermost peaks for that. But once we're satisfied with our peak picking, we can go to Save and Return. And that takes us out of the peak picking and returns us to the main window. The next step then is to integrate. So we'll go to the integrate. And since we're just zoomed in right now, we will expand fully. We're going to deselect our regions tool so that we can zoom in. We can select all the integral regions. You can see we have little green highlights on those, so they're now all selected. And then delete the selected regions, and then we can start integrating from scratch. So again, we go to our regions tool. For integration, we're not drawing boxes, but instead we simply go on one side of the peak, click and drag to the other side. And when you've got peaks that are close together, it's often helpful to zoom in a bit. So we're going to deselect this tool, zoom in, and then go back to our regions tool and zoom in on each of these triplets. I'm going to undo our zoom, and then again deselect the regions tool, otherwise we'd be integrating instead of zooming. Then drag, we've zoomed in, reselect our regions tool, and integrate each of the peaks. And right now you can see our peaks are overlapping the integral values at the bottom. We can adjust that using this double-headed vertical arrow. You can see it says shift baseline up or down. Usually if you hover on one of these icons, it will tell you what it's doing. This is shift spectrum left and right, shift up and down while pressing the left mouse button. So we'll click on that, and then as we roll the mouse up and down, you can see we're moving that baseline. So the peaks are no longer overlapping the regional value, the integral values. If we look at these integral values, we can see that this is close to 1, 1, 1, but this is 1.5. We can't have half a hydrogen, so this is most likely 3 hydrogens. We can adjust the values for the integrals here by putting our cursor on a peak, right-clicking. You can see we now have a menu. We can delete an integral if we don't want that one. We can also calibrate. Calibrate will bring up a window. It tells us right now that value is set to 1.5. We can change that by typing a 3. And when we click OK, it will set that to 3. And notice the others, the one that we have here, will also be adjusted. You can't set the value of just one peak. It will automatically readjust the others accordingly. And since we doubled this one, it's now 3. These are all 2. This looks good. We're going to back out of our previous zoom so we can see the entire spectrum. And again, these also make sense now. We have a 1.9, 0.98, which is essentially 1 and 2. So we have integrals now that all are approximately whole numbers, which is what we expect. Again, we're going to leave the integration module by the save and return. If you look at the toolbar, we don't have that, but we do have these little arrows, so we can push those over to see the rest of the tools, and we have now our return without saving and our return and save. So we'll click that, and now we have our spectrum again. Baseline's a little high for the number, so again we're going to go to this tool here, click and drag until we bring our baseline close to the integral values without actually overlapping them. So at this point we have a spectrum that we're happy with. We have peak picking, we have integrations. We can put it in a Word document. So for that we will simply open Word, scroll down, open a blank document, then we can go back to TopSpin. And before I copy and paste, I'm going to make one more point. For the integrations, we have 2 decimal places. This is fine. You really don't need more than that, since integration should be approximately whole numbers. Really, you could even go with 1 decimal place for an integral value. For the peak picking, we typically want to have at least 3 or 4 decimal places for the chemical shifts, especially when we're trying to calculate coupling constants. We want that accuracy. If you don't have the shifts and the integrations with a good number of decimal points, you can adjust that by going to this icon here. It looks like a gear wheel. This is the settings. Click on that, and you'll notice we have a long list. Here we have more preferences. We click on that. It's down here at the bottom. Spectra display preferences. We want to change those. And here we can go to peaks and integrals, and we have the change. And it tells us right now the integral labels are set to 2 decimal places. For the peak labels, or the shifts, it's set to 4. We could change that here if we did not have a good number for those, and then click OK. And then apply and close, and it would have those adjusted if, again, if you don't have enough accuracy with the chemical shifts, or if you have excessive number of decimal places in the integrations. Now that we have a spectrum we like, we can go to the bars here, and we can go to copy. This will copy the spectrum. Then we can go to our Word document and Control V to paste. It's a little difficult sometimes to see some of the splitting in this, so it's nice to do expansions on the high field or high shift region and the lower shift region. And so we can go back into TopSpin and again do our expansions, click and drag. And so now we have the high chemical shift region expanded. Again, we can copy. In addition to going here and going to copy, we also have the option of going here and copy to clipboard. And so we can copy our spectrum from this point, go into Word, and again paste. And then return to TopSpin, back out of that last zoom, and then zoom in on the low shift region. And again, copy, go to Word, and either Control V, or we can come here with the paste. I don't think it matters which one we use. We're pasting the spectrum again. And at this point we have the 3 expansions. We have an expansion on the entire spectrum, one on the upper shift region and another on the lower shift region. Just a quick comment here. If we go to full spectrum, you do see all this dead space, and again, this makes it even harder to read the shifts. So typically we don't want that, and so we do an expansion with the whole spectrum of just that region that actually has peaks, and then the upper and lower shift regions. So again, this does look a little bit different than the TopSpin 3, but the functionality here is very similar. We still have the peak picking, the integration buttons. That works a lot the same. The layout's a little different, the icons look a little different, but it's very much the same functionality.